Welcome to this special edition of Frequency Matters, the RF and Microwave Update Series. I'm Pat Hindle. I'm here with my co-host Gary LaRude, and we have a special guest today, Tim Bronner, Product Line Manager at Knowles Precision Devices. Welcome, Tim.
Thanks for having me.
Recently, you presented an interesting webinar that looked closely at RF passives in the 28 gigahertz band for small cells as a key applications for mmWave 5G, which is getting a lot of attention these days. Can you tell us about Knowles Precision Devices' history in working in these frequency ranges?
First, a little bit of context. Knowles Precision Devices is part of Knowles Electronics, and what we do is we focus on the passive components like RF components that I'll work with, our microwave filters, power dividers, couplers, things to that degree. And in addition to that, capacitors, mostly high Q, but also some very high capacitance density components. There is the audio side of Knowles that also works on the microphones, speakers, and other associated technologies. So the RF and microwave components got their start in a company called DLI, or Dielectric Laboratories, as it's commonly known of. It's now part of Knowles, which is a brand name that goes back to the mid-'70s. For the last 40 years, we've been working actively with key applications like radar, satellite communications, and have watched some of the key changes to the way systems are built in the block diagram. One of those changes we've supported is the increase in frequency that comes with growing bandwidth needs across the RF world, whether it is driven by SATCOM or the telecom industry.
So in addition to millimeter wave small cells, what other applications does your technology support?
Yeah, good question. We were developing surface mount components at millimeter wave long before it was what you could say is cool, right? The 5G at millimeter wave is just one slice of the interesting innovations and trends we've helped with as our customers have transitioned to these higher frequencies. And some of that's because the dielectrics we use are really well suited to making microwave filters because of material characteristics. Coefficient of thermal expansion, the frequency stability over temperature, and thin film manufacturing, as a few, offer higher repeatability, offer us the ability to really put together a nice package component.
So you've been doing this for a while now. What are some of the trends that you're seeing in those applications?
So as I mentioned, our technology is really well suited for manufacturing these devices. And I'd say there's a couple of ingredients in the technology that make us useful background, and then we can talk about those end-use technologies. One key part is our custom dielectrics. The company name Dye Labs suggests that one of the things we do is innovate dielectric materials. We utilize multiple dielectrics that we've developed internally to make these RF components much smaller than traditional alternatives using these high permittivity ceramics. Another key part is our thin film manufacturing process. We can make RF circuits and components at much higher tolerances than you would even find in very good precision PCB houses. That allows us to supply system builders with surface mount components that just work outside the box, without any annoying set at the test that some of us are used to experiencing with working with higher frequencies, especially if you're dealing with a hybrid package. So given those two core innovations, there are three trends that we take part in since we've gotten started doing this in the 70s. They all overlap, but it makes sense to look at each one of them in turn. First we can talk about is the plank or brick architecture and a shift from that to making a phased array antenna. Transceivers are orthogonal to the array in planar antenna where the push is to have everything in the same plane. Board space becomes a premium, and so does shrinking the RF components. Whether or not we're looking at a satellite communication in the S-band or point-to-point communications in V-band, it's an enabling factor for our customers. The second trend is the range of frequencies being used, and the use of higher frequencies driving those dimensional constraints even further. In satellite communications, for example, we've seen a push through the X through KU bands up to KA band, all in an effort to reach increased data throughput. Higher frequencies means smaller wavelengths, so of course the shrink in the array dimensions put a lot more pressure on these devices to fit inside of a smaller form factor. Both trends are enabling by our ability to reduce the footprint of the RF components for our customers by up to 20 times in some cases compared to alternative technology that's out there. And then the third trend that we should talk about is the trend to replace hybrid assembly manufacturing with surface mount. We continue to see that moving higher in frequencies as our customers continue to get more products and surface mount technology available to them, to make a multi-element arrays much more efficient and much cheaper to manufacture. This is a key concern when you're looking at a 5G base station, for example. an EW receiver, or even a satellite communication terminal, where you may be building thousands of them. So the ability to use standard surface mount components components and processes is a major cost savings. Doing this means having the access to those surface mount components, of course, throughout the entire block diagram. It doesn't do you any good to just have the filters. And our ability to produce repeatable surface mount components from S to V band helps you out a lot there. These trends are just some of the changes we've been participating in across various segments and are where our technology makes some of the greatest contributions.
So from the trends you've described, how is the technology a good fit for those applications?
Well, in terms of supporting the space segment, things that fly on satellites, for example, we've been doing this for over 20 years. Our components have flown on Mars rover, Juno, Jason, for just some of the public programs we can mention. We've worked with customers on qualification, but also on our own qualification programs in place. And by doing so, this approach has given us the ability to help our customers rapidly deploy, minimize the time it takes for them to do the additional qualification that's necessary for upscreening our components. We have well over 200 million accelerated life test hours collected with no failures, and continue to throw the usual suspects, temp cycle, shock, altitude, and humidity testing at our parts so the data is ready and available for our customers' needs. And we're seeing customers use more surface mount components in space applications to save on cost of manufacturing and weight. When it comes to the ground or and user segments, this is a key area where we've seen densification of the systems people are building, and the small form factor surface mount filters are definitely key in that application. Another shift in the RF world that has impacted the approach to SATCOM terminals is also radio architectures. We've watched direct sampling applied to L and S bands and can see that approach moving further at C and X band right now. Even though that we're seeing direct sampling up to S, then direct conversion from C and X band, and more traditional approaches, maybe perhaps with a complex IF. What's interesting is that in direct sampling systems, high Q bandpass filters are necessary to deal with noise aliasing. And then as we go up in frequency and add mixer conversion stages, we start to have to deal with the image and the LO cleanup. So from an L band and up, we can see these low SWaP systems that all need high performance RF components in small form factor surface mount packages. Space and satellite's a key part of our heritage, and it's why telecom infrastructure customers found the work we've done in the past for aerospace and defense components for the 5G millimeter wave industry so compelling.
So describe the range of products that you're supplying to the market in addition to the bandpass filters you've discussed.
Right, so I would say that we're an RF and microwave solutions provider whose technology can solve for certain high frequency problems in certain key parts of the RF circuit. Filters is a good example, but another good example would be the power dividers and combiners that we offer. In the webinar that you guys asked about at the beginning, we talked about building a feed network. That is, how do I equally distribute RF over 16 or 64 outputs and keep everything in small form factor, temp stable, and in phase? And that's a real world example of some of the other things that we get asked to do. If we go back to those key ingredients, high dielectric enabling small form factors and our thin film technology allow for the high repeatability components that just work. You can see how they can be applied to a range of places in the block diagram in a low SWaP system. And those key ingredients are helpful to the RF engineer, whether they're building an X-band receiver or a 28 gigahertz small cell.
We've been speaking with Tim Bronner, the product line manager for thin film products at Knowles Precision Devices. Tim, thanks for joining us today and telling us about some of the really interesting work that you're doing.
No problem, guys. Thanks for having me.